Hello everyone, welcome back to my channel. My name is Dr. Yogita Bisht, and in today's video, we will try to understand the electronic configuration of different atoms with the help of some examples. So this is the fifth part of my video series called as electronic configuration. In the earlier part, we tried to understand the different quantum number and the principle which form the basis for these electronic configuration. These principles are Aufbau Principle, Pauli Exclusion Principle and Hund's rule. So we will try to apply all those knowledge to find the exact electronic configuration. Okay, so we will start with first meaning of the electronic configuration. What do you mean by electronic configuration? So electronic configuration is nothing but the distribution of electron in the orbitals. Okay, and these are governed by the different rules. Okay, so there are two ways of representing these electronic configuration. Two ways representation. First is, how do we write the electron in S, P or D notation? Okay, how many electrons will be there in S, how many are there in P orbital, how many present in the D orbital. So such type of notation, with the help of this we can represent the electronic configuration. For example, for hydrogen it is 1s1. Okay, similarly we have another way of representation, that is called orbital diagram. So we represent it with the help of these boxes. So this is S orbital, this is P orbital, and this is D orbital. Okay, so how do we represent electron in this orbital? With the help of up spin and down spin. Depending upon the number of electrons, here we write the number of electrons in terms of numeric values like 1, 2, 3 and so and so. Here we write the electron in terms of the up spin and the down spin, like this. Okay, so depending upon the electrons which are available to an atom, we are going to represent their configuration. Okay, so if you remember all the rules, then we can quickly start. If you don't remember, I would highly suggest to go through the earlier part of these videos, this video series. I will provide the link, and that will help you to understand this particular concept easily. Okay, so we will start with a very basic example, and then we'll move to a little bit complicated examples. Okay, so first we will start with hydrogen. Okay, I'll also write the number of electrons available. So its number of electron available for hydrogen is 1. So we are going to represent it as 1s1. Then next come in the list is helium. How many electrons are there for this? 2 electrons, right? So we are going to represent it as 1s2. Why? Because if you can recall, according to the Aufbau principle, the electrons are filled according to their energy level. So the energy level having the minimum energy will be filled first. So 1s has the lowest energy, followed by 2s, then 2p, then 3s, 3p, followed by 4s, then 3d, and so and so. Okay, please try to recall that. Okay, then the third one is lithium. Now the maximum number of electron which can occupy in a single orbital is 2 according to the Pauli exclusion principle. So number of electrons for lithium available are 3. So 1s2 is already filled. So the next available orbital is 2s2. 2s, right? But only 1 electron is available. So that is why we are going to write it like this. And if I have to represent in the orbital notation, I'll be representing it at like this. Okay, like this, and this one as this is 1s2 and this is 2s1. Okay, then the fourth one is beryllium, which has 4 electrons. So we are going to represent it as 1s2. Next electron will come in the 2s2. So the representation is like this. 1s2, 2s2. Right? Then the fifth one is boron, which has number of electron available as 5. So it will be 1s2, 2s2. So the maximum number of electron which can be occupied in s orbital is 2. That is why we have to move to the next orbital. So according to the Aufbau principle, the next available orbital is 2p orbital. So obviously the next electron, so 4 is already been occupied, 1 electron is left. So the next electron orbital that is going to occupy, the electron is going to occupy is 2p1. So the representation would be 1s2, 2s2 and 2p1. Right? Then of course the next one is carbon with 6 electrons. So we are going to represent it as 1s2, 2s2. So we are still left with the degenerated orbital in 2p orbital. So 2p subshell. So the next electron is going to occupy the 2p orbital. Okay. Similarly, next is nitrogen. So it will be 1s2, 2s2, 2p3. We can also show the representation like this. 1, 2, and for nitrogen it will be 1s2, 2s2 and 2p3. So according to the Hund's rule, first we will fill all the p orbital singly filled, right, and then pairing will start. Alright, and the 8th one is oxygen with total number of electron as 8. So it will be 1s2, 2s2, 2p4. Similarly, the 9th would be fluorine with the number of electron as 9. So it will be 1s2, 2s2, 2p5. You can show it also. Okay, I'm doing it little quickly. If you find it difficult, you can comment down below. I'll rewrite it later on. Okay, so this is 4 electron. Similarly, for fluorine, 1s2, 2s2 and 2p5. Okay, so that means for 2p, the maximum number of electron that can come in 2p is 6. So the next element that we are talking about is neon. So maximum number, the number of electrons available for neon is 10. So 1s2, 2s2 and 2p6. So 1s2, 2s2 and 2p6. So this is the representation for the neon. I stopped at neon right now. Why? Because if you remember the periodic table, neon is the noble gas, right? So because it has a fully filled orbital. So p can have maximum 6 electron and all are filled here. So that's why sometimes we represent neon like this and then write the rest of the configuration. For example, I'll tell you next element that come in this list is sodium. Okay, sodium has available electron as 11. So one way of representing it is 1s2, 2s2, 2p6 and the next available energy level is 3s. So the next electron should come in the 3s orbitals, right? So either we can write like this or we can also club all this and instead we can write neon. So the normally how do we represent sodium? We represent it like this: neon followed by 3s1. Okay, then after sodium we have magnesium. And how do we represent magnesium? We are going to write neon followed by 3s2. What about the next one? Next one is aluminium. Aluminium has available electron as 13. So we will be writing neon 3s2. This will make 12 electron. What about the 13th electron? So the next available orbital is 3p orbital, right? So next orbital where the electron is going to go is 3p1, right? So similarly we can write for the rest of it. So I'm just writing the number of electrons available for this element, and if you understood everything till now, please comment below the electronic configuration of rest of the elements that I am mentioning here. It is very simple to write. Okay, so for silicon the available electron is 14. Next we have phosphorus, available electron 15. Then we have sulfur, available electron 16. Then we have chlorine with available electron as 17. And then we have argon with available electron of 18. I'll write the configuration for argon. For the rest you are supposed to write in the comment box. Okay, and if you don't understand these configuration, do let me know. I'll answer this in the comment box. Okay, so for this it will be neon 3s2 3p6. Okay, total number of electron as 18. So again argon will be considered as noble gas. Why? Because the octet is complete, so it has 18 electron. So afterwards, like for potassium, it has 18 electron, right? So if I have to write the configuration of potassium, which is 19, so what I am going to do is, instead of writing neon 3s2 3p6 4s1, what I am going to do is I am going to club all this, and instead I'll write just argon. Okay, so its representation is also like argon and 4s1. Okay, why 4s1? Because the next available energy level is 4s. Okay, all right. Then the next one is calcium 20. So how we are going to represent it as argon 4s2. Okay, the next one after calcium we start with the D block elements. Okay, this is important. So we are starting with the scandium, that is Sc, and the available electron is 21. So till calcium we have 20 electrons, so we represent it with argon and 4s2. What about the next electron? Okay, so for that we have to check the list. So after 4s the next available orbital is 3d. Okay, so the next electron is going to go into the 3d orbital. So its representation would be argon 3d1 4s2. Okay, although we are filling 4s first, but normally we write 3d first and then 4s2. Okay, then after scandium we have titanium with number of electrons available 22. So it is argon 3d2 4s2. Okay, similarly the next one is after titanium we have vanadium with atomic number 23. So it will be argon 3d3 4s2. Okay, then we have 24 chromium with atomic number 24. Its representation would be, any guess? It will be 3d4 4s2. You must be considering this as a configuration, but this is wrong. Rather its configuration is argon 3d5 4s1. Okay, this is the special case, and why this is so I'll explain that in the next video. Okay, all the exceptions. Then after chromium we have manganese with atomic number 25. So its representation is argon 3d5 4s2. Then we have iron with 26 atomic number. So it's argon followed by 3d6 4s2. Okay, then we have, after iron we have cobalt with atomic number 27. So the configuration would be argon 3d7 4s2. Then after cobalt we have nickel with atomic number 28, and the representation for nickel is 3d8 4s2. And then we have copper with atomic number 29, and its representation should be 3d9 4s2, but again this is the wrong representation. Okay, its actual representation is argon 3d10 4s1. Okay, this is also a special case about which I am going to talk about in the next video. Why? Because it is little bit the lengthy topic, and I'll explain the reason behind it also in the next video. Okay, and lastly we have zinc with electrons available 30. So how we are going to arrange them? Argon 3d10 4s2. Okay, so these are the different electronic configuration of different atoms. I hope you understood everything. Okay, except of course these exception. Why these exceptions are there? All these thing informations we are going to discuss in the next class. And if you don't understand anything, any configuration here, do let me know. I'll re-explain this. Okay, so I'll see you in the next video. Thank you.